All right, what is up, y'all? Y'all might have heard the news by now that Tom Brady is a Tampa Bay Buccaneer. I hope he wins, unless I want the Broncos to win. But if Broncos don't win, which they haven't, so I want him to win. I don't know how the Patriots managed to not sign him again, but geez, how do you do that? How do you not sign Tom Brady? So, fun fact, I've been a Bronco fan my entire life. However, I have a Tampa Bay Buccaneers keychain, their little helmet, and kind of beanie baby of the Tampa Bay Buccaneers. Because in, I think it was 2003, the Buccaneers beat the Raiders in the Super Bowl. And if you like the Broncos, you hate the Raiders. So it was a big day. The Raiders losing the Super Bowl was great. Great. So, anywho, I hope you realize the graphing method sucks, but make sure you know it for your quiz. Today's substitution, not the best either, but maybe a step up from the last one. So, let's see. Basically, it's the same thing. They give us, same idea. They give us two equations, and you want to see where would these two things intersect. They're all some form of line or graphical shape thingy, and they intersect somewhere. We're trying to see where do they intersect. So we can do that by graphing like we did last time, or there's more methods we'll learn today and the next days of how to find intersection. And it's kind of up to you what you want, but depending on the quiz, they might tell you to do it this way. So then you got it. Substitution. You need to solve for one variable first, and then you will plug in to the other equation. So in this one, they want to, wow, spelling, geez. Solve for y, and I'm going to label this equation 1. Equation 2. They're solving for y in equation 1. You see, it's easier for that one because this one has 3y. I have to divide this one. If I just move it over there, I've solved for y. So y equals negative x plus uno. All right, cool. I'm going to plug that into equation 2. So 4x plus 3, nope, not y. 3 negative x plus 1. It said y, but I said y is this. So I substituted that in. Equals 38. So 4x distribute minus 3x plus 3 is 38. Combine like terms when possible. 4x minus 3x is x, plus 3 is 38. Subtract 3, x is 35. Okay, we are almost there. Did I totally butcher that? X is negative 7. What? What did I do? Oh, jeez. Y'all, I did it. I wrote it wrong. That's supposed to say 15. Shucks. Read that again. X plus y is 15 4x plus 3y 38. Done. All right, starting again. You want to solve for one variable. First, and then you want to plug that into the other equation. So for this one, they solve for y, and I'm going to label this equation 1, equation 2, and they solve for y in equation 1, because you see here 3y. If I move stuff over, I have to divide by 3, and I don't want fractions. Fractions are gross. Here, if I just move x over, boom, done. And again, you could solve for x first or y first. It does not matter. So y will be move over x, negative x plus 15. I wrote it right this time. So I'm going to plug that into equation 2. Equation 2 says 4x plus 3y, y, negative x plus 15, not y. Negative x plus 15 equals 38. Distribute. Boom, boom. 4x minus 3x plus 45 is 38. Combine when possible. 4x minus 3x is 1x plus 45 is 38. And you subtract 45, that means x is negative 7. We are not done yet. There are two variables here, x and y. I need to solve for both x and y in my system of equations. System of equations meaning more than one equation, in this case 2. So you're going to plug this back in to either equation, x plus y, x plus y is 15, x is negative 7, plus y is 15. I need to add 7. That means y is 22. Basically done. You want to write that into a coordinate for on a graph. Where would that solution be? Negative 7, 22. And you will notice that if you did the graphing method for the same thing, obviously you'd have to go down 22 spaces, but they would intersect that same way if you'd done it the graphing method. And is there another one? There's more. All right. From the last section, you should remember that we said you could have intersections where there's a solution. You could have no intersection, meaning no solution, if two lines are parallel, meaning they have the same slope. Or you could have infinitely many solutions if they're the same line that you find out. So 2x minus 8y is 6. X minus 4y is 8. This is kind of like is a slope 0 or undefined difference, where a lot of people get confused. Is there no solution or infinitely many solutions? So you want to be careful. So substitution method. I no me gusta fractions or dividing. So x is by itself right here. So if I take equation 2 and move over 4y, I will have x equals 4y plus 8. Cool, I got x. Now I'm going to plug that in to equation 1 when I see an x. So it's going to be 2, oh, it says x. That means I'm going to write 4y plus 8, and then minus 8y equals 6. Distribute 8y plus 16 minus 8y equals 6. 8y minus 8y, that cancels. what is happening. 16 equals 6. Did 16 equal 6? I don't think so. If you get some number equals not that number, there is no solution. What does that mean from a graphical standpoint or these equations? It means they'd be parallel. Let's check to see if that is true. So remember, to see if things are parallel, you need to put them in slope-intercept form, check the slope. So equation 1, right? If I solve for slope-intercept form, I'm going to solve for y. So subtract 2x. Divide by 8. Again, really all you need to worry about is the slope. So you don't need to worry about the y-intercept. Negative divided by negative is a positive. Negative 6 over 8. That means y is 1/4 x minus, what was that, 3/4? And equation 2, I would subtract over x, so negative x plus 8. Divide by negative 4. Negative divided by negative is a positive. 8 divided by negative 4 minus 2. So you see they have the same slopes. Same slope means they're parallel, means they're never going to intersect. The y-intercepts are different. If the y-intercepts were the same, they'd be the same line, which would mean there'd be infinitely many solutions. However, different y-intercepts, same slopes, parallel lines, never going to intersect. So you can probably guess what the next example is going to be. Spoiler, there's going to be infinitely many solutions. But what does that look like? When you come across it, you want to make sure that you don't make the mistake of saying no solution. So, oh, gross. Fractions. Why they gotta do this to me? They know I gotta teach this. Why can't they make it easy? All right. Gross. All right, so the second equation, if I labeled this equation 1, equation 2, there's a whole lot of dividing I'd have to do to solve for y. This one, I could solve by x by moving that over, divided by a negative, but then I have fractions, no make use of fractions. So I'm going to take equation 1, and I'm going to multiply everything by 2, which will mean I'll get y all by itself. So after multiplying everything by 2, I'll get y equals 4 minus 2x. Yes, I like this. I will then plug that in to equation 2. So I have 6x plus 3y, but y is 4 minus 2x. 3, 4 minus 2x. Please, please, please put it in parentheses. Otherwise, if you don't distribute, you'll get it wrong every single time. And you don't want to be that guy. So we are going to distribute. So 6x plus 12 minus 6x equals 12. 6x and 6x, Shazam, Shazam, cancel. 12 equals 12. 12 does equal 12. What a coinky dink. If you get some number equals the same number, you might get 0 equals 0, or you might get 1 equals 1, 12 equals 12, it doesn't matter. If you get some number equals another of that same number, there is infinitely many solutions, or if you want to write the word infinitely many solutions, go for it. Okay, doesn't matter, these are the same thing. And those are basically the different examples for this section of what's going to happen. You might want to multiply to clear the fractions. You might want to move stuff over first. You get to pick. Do I want to do this equation or that equation? You can make it easier or hard on yourself, and you'll kind of, as you do it, see, I probably should have done that differently. Yeah, you might notice in this section that your answers may not be whole numbers. Graphing, they kind of are nice to you and expect that we're not going to make you guess where does this intersect by graphing, but substitution, you might now start getting some fractions as your answers. So yeah, that is it. Hope y'all don't hate these. Catch you later.